Okay, let us now take a look at question 3.4. Question 3.4, in the figure below, GF is parallel to FC. GF is parallel to FC and BE is parallel to CD. Then we are also given that the length of AC is 6 centimeters, and then we are given the ratio AB to BC is equals to what? 2, or you can just say 2 to 1. 2 to 1. That is the ratio of AB to BC. 2K K. I'm sure by now you understand why I'm having 2K then. Alright. If not, please make sure that you go and watch the previous videos where we are talking about proportionality, where we are answering questions on proportionality. The length of AC, 6 centimeters. All right. Then let's come to the questions. Let's first indicate our AB, 2K, our BC, K, and the length of AC there, 6 centimeters. Now, calculate with reasons the ratio AH to ED. Now, where is AH? Where is ED? Here is AH. AH. And then we have what? ED. You see now AH and ED. The ratio AH to ED. We are not getting it from what? From proportionality theory, where we are having a triangle and then we are having a line drawn parallel to one side of a triangle, whereby it divides the other sides what? Proportionally. Therefore, it means what? We need to determine, we can say the length of what? Of AH, and also the length of what? Of ED, and then find the ratio of what? Of the two lengths. That is the approach that we are going to take. All right, now let us now focus on triangle. Let us now focus on triangle. I'm trying to get what AH first, ne? So let's focus on triangle AFC. Triangle AFC. You see, when we are in triangle AFC, we are having FC being parallel to GB, and we are having what? AE here. Let me draw it again. Let me draw it again so that it is clear. I'm saying we are focusing on what? I'm just going to extract triangle AFC from the diagram. Here is our triangle AFC. And we also have what? AE. And we also have GHB. Here is HGB. And we know that GB is parallel to what? To FC. And we know that AB is 2K, and then BC is what? BC is K. So from there, I'm going to get what? I'm going to get AH. In fact, I'm going to get the ratio what? AH is equals to HE. I mean AH to HE then in a way I'll be able to get what? The length of AH in terms of something. No? All right, let's do that. Then we say we are focusing on triangle what? Triangle AFC. Then we say AH2, we are now applying what? Proportionality theorem. Ne? AH2 HE will be equals to AB2 BC. And the reason for this, proportionality theorem. Don't forget to give the what? The parallel lines. GB is parallel to FC. Therefore, AH2 HE will be AB 2K BC K 2K over K will just be what? 2 over 1. Therefore, it means what? The length of AH will be 2 something. AH 2 something and HE 1 something. So let's choose a different letter. Let's take what? P, ne? 2P. Therefore, HE will be just be what? Will just be P. Okay. Then I'm done. I can erase this one. I'm done. So now I need to get to what? To ED, ne? To ED. So for ED, I'm going to concentrate in triangle. I think it's best that we indicate the triangle. Ne? Write down the triangle. In triangle ADC. Triangle ADC. But I'm going to draw it down here again for you. Ne? Extract it from the diagram. I think it will be easier for you to see what is happening. Then let's get to triangle ADC. Triangle ADC. And in our triangle ADC, we are having what? Line EB, which is parallel to DC. And we have 2K. We have what? We have K. Therefore, it means now we can find the ratio of what? AE to ED. Then we can get the length of ED in terms of something. Then we'll say AE to ED will be equals to what? AB to BC. Again, proportionality theorem, from which two parallel lines EB is parallel to DC. Therefore, AE to ED will be equals to what? 2K over K, which is 2 over 1. Therefore, this means what? AE will be 2 something. Here is AE. Let me get AE here. Here is AE. Let me now take what? The letter S. 2S will be the length of what? Of AE. And then from the ED will just be what? 1, which will just be what? S. Of which will just be S. Then let us erase this one. Right. So now I'm having what? Remember, I want the ratio AH to ED. AH to ED. But now I have AH. My AH is 2P. And then my ED is what? Is S. I'm now having what? 2 different what? Letters. Ne? So it means what? I need to write either ED in terms of P or AH in terms of what? In terms of S. So let us now say, let me bring this down. Let me make a copy of this and then bring it down. Let us take this one. Let us take this one. Let us take this one. Okay. going to put it here. Let's put it here and resize it nicely and position it yes, position it there. All right, then now we can say let's choose to what, let's write what, p in terms of what, of s. You can either write s in terms of p in terms of s. Let us write p in terms of what, of s. How do we do that? We will say, let's look at what ae is equals to what, 2s, but also ae is equals to what, 2p plus p, ne? Which is 3p. Therefore it means what, it means 3p is equals to 2s. Then divide both sides by 3. We get p is equals to 2s divided by what, by 3. That is what we will get. Now therefore now we can say now that we have p in terms of what, in terms of s, then now we can say what is ah. Ah is 2p, but what is p? P is 2s divided by 3. Therefore ah will be what, 4s divided by 3. And then what is ed? Ed is what, here is on our diagram. Ed is just what, s. Therefore it means what, the ratio ah to ed, let's now write it as a fraction. First write it as a fraction. It will be ah is 4s divided by 3, then divided by ed, let's use the division symbol, is what, is s. And then from there let's manipulate with algebra. 4s divided by 3 multiplied by 1 over s, and then s cancels s, or s divided by s is 1. Then we're left with what, 4 times 1 4, 3 times 1 3. Therefore it means what, the ratio ah to, now you can write it as a ratio, to ed will be equals to, okay, firstly not as a ratio, still as a fraction, ah to ed is equals to 4 over 3. Then as a ratio, ah to ed will be equals to 4 to 3. Then that will be our ratio ah to ed is 4 is to 3. All right. Then b says write down the ratio be to cd. Let's take our diagram here. Let's take our diagram. Let's bring it. Let us bring it down here. Let us bring it down here. All right. Here we go. Now we need to prove that BE, we need to calculate the ratio of what? BE to CD. BE over CD. Here is BE. There is what? CD. Then with this one, we just need to prove triangle AEB is similar to triangle ADC. Prove triangle ADC, and then from there you write your ratios in terms of what? You write down your ratios from the similar triangles, and then from there you get your what? BECD. It will be easier for us because if we concentrate in triangle what? ADC, then you'll see that it's obvious that triangle AEB is similar to triangle what? ADC. But it's still very important to what? To write down all the steps to actually what? Prove that the two triangles are what? Are similar. All right, whenever you're having a triangle and a line drawn parallel to one side, then we know that that line will divide the other two sides what? Proportionally. Then the two triangles will always be what? Similar. Because we'll always have a what? A common angle, and then the other sides, the other angles will be equal through what? Through corresponding angles. Let's do that. Let me show you what we mean. We say now in triangle AEB, AEB, because triangle E will be equals to triangle D, ne, corresponding angles. Therefore, and the order is important. And triangle, we say what? A again, which should be what? The common triangle. A, D. Why? Because that we know that E must be equals to D, and we already know that A is equals to A, the common angle. Therefore, automatically B will be equals to what? C. No? That is how you identify or write down your what? Your triangles. Remember, order is very important. Then we say 1, 1, 2, 3. A little bit of space. 1, 2, 3. We said angle A is equals to angle A, common, and then we say angle E is equals to angle D, reason corresponding angles from which two parallel lines? EB is parallel to DC. Remember, we are in triangle what? ADC. Then lastly we say angle B will be equals to what? Angle C. Again, the reason corresponding angles EB is parallel to DC. You see, B will be equals to what? C. Or the reason for number 3 can even say what? Remaining angles. Ne? Therefore, it means what? In that order, 1, 2, 3, triangle AEB is similar to, in that order, 1, 2, 3, triangle ADC. And the reason, angle, angle, angle. And then from there, we can write down our ratios. AE over AD. I'm sure now you know how to write down the ratios. Ne? Is equals to EB over DC is equals to EB over AC. And our reason will be similar triangles. Similar triangles. Let me get rid of this so that we can create some space. Space. Okay. Yes. And then from there, what do we want? We want the ratio EB to CD, which is our ratio here. Therefore, we know that EB to DC or BE to CD, ne? We are talking about the same line segment, will be equals to, now, if we take AB to AC, AB to AC, we'll be able to get something. Ne? You see on our diagram, AB is 2K, and then AC, the whole of AC will be what? 2K plus K, which is equals to what? 3K. Therefore, 2K over 3K will just be what? 2 over 3. K will cancel K. Therefore, we can take our what? AB to AC. And then from there, we are seeing EB to, or we can rewrite it as what? BE. BE to CD is perfectly fine. AB 2K over AC, we said it's what? Is 3K. The which of which will be equals to what? K divided by K is 1. Then we are left with what? 2 over 3. Therefore, the ratio BE to CD will be equals to 2 to 3. Right, and then lastly, let me take our diagram here, put it here, our diagram, and put it here. Reposition. All right, now we are told that if HE is equals to 2 centimeters, calculate the value of what? The product of AD and HE. We know HE is 2 centimeters, but what is AD? What is AD? Here is AD. You see the length of AD. What is AD? AD is actually what? In terms of S, 2S plus S. You see? AE plus ED, of which it is equals to what? 3S. AD is equals to 3S. But now we need what? We need the actual value. Ne? We need the actual value. But let's remember, ne? When we're in question what? 3.4.1. We had our equation 3p is equals to what? 2s. And then from there, what are we saying? We are saying what can be what can be, we now need to write what? S in terms of what? Of p. Maybe the question would be, why necessarily S in terms of p, not p in terms of S? Let's go back to the diagram and the given the information we're given. We know that HE is what? 2 centimeters. But when we go to our diagram, HE is also what? P. So we realize that if we write S in terms of P, then we'll actually be able to find what? The value of P. We actually know that the value of P is what? Is actually what? 2 centimeters in question 3.4.2. So we are saying S will be equals to what? 3P over 2. Then we are saying HE is equals to 2. Therefore, P will be equals to what? Will be equals to 2, because HE is also equals to what? 2. Ne? Therefore, what will be AD? Then now we can say AD will be equals to 3 multiplied by, remember we said AD is equals to what? S. Then what is S? S is 3P divided by 2. This will be equals to 3 multiplied by 3 times P is 2, all divided by what? By 2, of which it will be equals to what? 9. Therefore, it means what? The product AD, the product AD, the product of AD and HE, AD multiplied by HE will be equals to what? 9 multiplied by 2, which will be equals to 18. Alright, this brings us to the end of question 3.4.